Yo, time to wake 'em up!
Hello and welcome to Discover 360. I hope you enjoyed this channel. It is dedicated to artificial intelligence, travel and tech.
Yo, check the mic, 1, 2.
Don't forget to subscribe.
Thanks for watching.
Next cipher begin!
All right, let's talk about something huge. We're way past the point of AI that just, answers our questions. We are now building AI that acts. We're talking about agents that can take on complex goals all by themselves. Now, this is obviously a massive leap forward, but it also rips open a whole new frontier of security threats that, honestly, we're just now starting to wrap our heads around. And it all really kicks off with a question that sounds like it's straight out of a sci-fi movie, but it's a very real engineering problem today. What happens when these autonomous agents start talking to each other? How in the world do we secure systems where trust isn't based on rigid, predictable code anymore, but on flexible and maybe even manipulative natural language? So what are we even talking about when we say agentic AI? Well, unlike a chatbot that just kind of sits there and reacts to what you type, an agent is proactive. You give it a big, high-level goal, something like, hey, plan the company offsite, and it just goes. It can figure out all the steps on its own, researching flights, booking hotels, juggling calendars, without you holding its hand through every single step. That autonomy? That's the real game changer here. Okay, so this is a really big deal because it completely flips our whole idea of security on its head. With your traditional software, everything is pre-programmed, it's predictable, so we focus on making sure the code itself is solid. But with agentic AI, the workflow is made up on the fly. Its behavior is adaptive, unpredictable. So security has to get way bigger. It's not just about the code anymore. It's about the agent's data, its memory, and maybe most importantly, its own logic. And right here, this is the absolute crux of the problem. For decades, the foundation of computer security has been separating code, which is the instructions, from data, which is just stuff. But with agents, that line gets super blurry. A piece of text it finds on a web page isn't just data anymore. The agent might see it as a command. This is basically a supercharged version of a classic hack called code injection, where an attacker tricks a system into running malicious instructions that were disguised as harmless data. So where does an attacker start? Well, this new reality points to our first major vulnerability: attacking an agent's mind, corrupting its knowledge base and its memory. You've probably heard of this, but most agents use something called retrieval augmented generation, or RAG for short. The idea is actually super simple. You ask a question, the agent goes and finds relevant documents from its database, and then it uses that info to put together an answer for you. It's basically like giving the AI an open book exam. So, what happens when that open book, the library the AI is studying from, is full of lies? This is where things start to get really dangerous. And these attacks can be unbelievably sneaky. An attacker could hide malicious commands in the metadata of an image, something you'd never see. Or get this one: error message poisoning. An attacker deliberately causes an error, and the error message they craft has a hidden command in it. The system, doing its job, logs that error message as just plain text. Later, when an agent pulls up that log to figure out what went wrong, it reads the log, finds the hidden command, and bam, executes it. It's a brilliant and honestly a deeply worrying way to attack these systems. So what does this all mean? It means attackers don't even have to look for bugs in the code anymore. Why bother? They can just poison the data the agent is reading and trick it into using its own powerful, perfectly legitimate tools, like its code interpreter or its file access, to do malicious things. This is effectively remote code execution, which is the absolute holy grail for hackers, and they can achieve it without exploiting a single line of buggy code. Okay, so a single rogue agent is, well, it's bad, really bad. But these things aren't being built to work alone. They're being designed as teams of collaborating agents. And that's where the problem goes from a single fire to a full-blown epidemic. Look, one compromised agent? That's a problem, sure. You can probably contain it. But a network of them? That can trigger cascading failures, where one bad apple literally poisons the whole barrel, and the damage just explodes exponentially. And the reason why is kind of terrifying. In old-school systems, trust is built on strict, rigid rules and access control lists. But agents, they just talk to each other. They use plain English. And that means a compromised agent can basically socially engineer another, more powerful agent into doing something really dangerous. This opens up a whole new playbook for attackers. Think about the confused deputy problem. A low-level agent with almost no permissions tricks the high-level admin agent into using its God mode powers for the attacker. Or even crazier, circular verification loops. An attacker compromises not just the agent doing the work, but also the auditor agent that's supposed to be checking its work. The two compromised agents then work together, telling everyone that everything's fine, creating this perfect illusion of security while all sorts of bad stuff is happening completely undetected. All right, I know this all sounds pretty dire. So what do we do about it? How do we even start to defend against this stuff? Well, the answer isn't some magic silver bullet. It's actually a classic security idea just applied to this new, really complex world. We need to use defense in depth. You can just think of it like building a medieval castle, right? You don't just count on one big wall. You have a moat, then an outer wall, then an inner wall, and you've got guards at every single gate. The idea is, if one layer of defense fails, there's another one right behind it ready to catch the attack. And to build that castle, we have to make one absolutely critical mental shift. That large language model, the brain of the agent, it's brilliant, it's creative, but it's also unpredictable. We have to stop trusting it. We must start treating the LLM as an untrusted planner. It can come up with any plan it wants, but every single proposal it makes has to be checked by a separate, simple, rule-based security layer before it ever gets to touch the real world. This whole philosophy breaks down into a 4-layer defense strategy. It's a full stack. First, at the data level, you clean up everything coming in before it has a chance to poison the well. Next, at the inference level, you build a hard wall between instructions and data. But the most critical part is the agentic logic level. This is a hard-coded gatekeeper that has to approve the agent's plans. And finally, at the environment level, you lock down the whole infrastructure the agent lives in. So that agentic logic layer, that's where the real muscle is. And this is not AI checking AI, no way. This is old-school, hard-coded rules. We use sandboxing to make sure that even if an agent does go rogue, the damage is contained. We enforce the principle of least privilege, meaning don't give an agent the keys to the kingdom if all it needs to do is read one single file. And we use policy enforcement points. That's the hard-coded gate outside the AI that says yes or no to every single action. The AI can propose, but the policy decides, period. So with all these automated defenses, you might think we're done. But there's one last and maybe the most important layer of security. Us, the humans. But our role has to change a bit. Now, obviously, we can't be sitting there hitting approve for every single tiny thing the agent does that would completely defeat the point, so we have to be smart about it. This means demanding explicit human confirmation for the really big stuff, like, deleting a production database. It means creating tamper-proof audit logs so we can always go back and see exactly what an agent was thinking. And critically, it means building transparent interfaces that don't just show us what an agent did, but what it was planning to do and why. And really, that leaves us with the million-dollar question, doesn't it? We've built these incredible systems to operate at a speed and scale that we just can't match. The great challenge for all of us now is not just building more powerful agents, but building security and oversight systems that are just as smart, while making sure they stay grounded, predictable, and fundamentally under our control. That is the new frontier.